Alright, here we go. Today we're factoring polynomials, and we're using a new technique called splitting the middle. Here's the middle, you split the middle. That's what we're doing today. It goes like this. A little review from what we've been doing lately. We've been factoring by grouping. And that process goes something like this. You start with a polynomial. Suppose this is given, and you note that you're adding, for example in this one, you're adding 4 items, 4 terms. We know that there are 4 terms because terms are partitioned by pluses or minuses. These don't count, these are negative, these are attached to the number. So we have plus, plus, plus. That makes 4 of these. There's a famous law that says we can group those guys and group those ones, and that's called associative law of addition. Now once we do that, we can try and look at the first group and see if there's anything we could factor out of these ones. And in fact, in here there is something we could factor. We could factor out an x, and that would leave a 2x plus a 3 in there. And out of this we could factor out a negative 3. And if we factor out a negative 3, that would leave a positive 2x here, and that would leave a positive 3. And there's an easy way to check to see if we did that right. You would just distribute this back in there. Negative 3 times 2x, that would give you negative 6x. Negative 3 times 3, that would give you negative 9x. And you see we did it correctly. That's called the distributive law. Okay, the next thing you notice is you can think to yourself, whoa, it looks like someone distributed this quantity right here, the 2x plus 3 and the 2x plus 3. You say maybe we can undistribute that, and so we would make a separate parentheses here for that, and we would go on and factor the 2x plus 3, and we would try to think what's left over if you unfactor that 2x plus 3. Well, there would be an x left there, and there would be a negative 3 left in there. Again, it's easy to check to see if we did this correctly. You would just take this quantity and you distribute it there, and you distribute it there using the distributive law, and that would get you back to the previous quantity. Okay? Again, this is the distributive law, and now we're done. Now we've in fact factored it. At the beginning we had 4 items being added, and now we have 2 items being multiplied together. That's what we mean when we say factor. Factor means break up into multiples, and we did it in a beautiful way here. Okay, let's try another example and see what the issue is here. Alright, so we just did this example by grouping, and now let me tell you what could possibly what could possibly go wrong. And that's the following. Sometimes the problems won't be presented to us in this way, 3x plus negative 6x. In fact, there's a tendency for people to combine like terms, and most people would simplify this. Instead of writing 3x plus negative 6x, they would simplify it, and they would give you something like, this is exactly the problem with factoring by grouping. Instead of giving you this, they would give you that, which is really equivalent. 3x plus negative 6x, it's the same as negative 3x. Negative 3x is the same thing as positive 3x is a negative 6x. So it's the same thing, but this way of writing it is nice because we can factor by grouping. We have 4 items, and we can group these 2 and we can group those 2. The trouble with this one is that you can't really group. You can't do it by grouping because there's only 3 items, so you can't. It's not going to work. You could try it, and it'd only get you 1 or 2 steps, and then you'd be stuck. So that's where this comes in. This incredible idea here that we call splitting the middle term. In fact, what we want to do in cases like this, where you have the 3x, is to unsimplify it, to break it up into the previous form, so that once you unsimplify it, you can do the same technique that we did previously. So that's what we're going to do here. We will take the 3x, and instead of writing negative 3x, we will write 3x plus negative 6x. Now here's a little trouble. If this is the only part you see, you wouldn't know that this might be a good way to split it up, and then you'd be in trouble. So there's a very important secret to discuss here. How do you write? What would be the good way to factor that? Because there could be other ways. I mean, somebody could have said maybe I should do negative 10x's and positive 7x's, because that would give you negative 3, or some other combination. There's really infinite many. So there's a trick to this, but supposing you found the right way of splitting in the middle term. You take the middle term and you split it into 2, and now you have 4 items, and now you can group the first 2 and the last 2, as we did before, Out of this group we factor out an x, and that leaves you with 2x plus 3. That would leave you negative 3, 2x plus 3, and of course that would lead to a successful factorization, x plus negative 3 times 2x plus 3. This part is kind of boring, we did it already, but the important thing here is this brilliant idea that when someone gives you this middle term like this, it happens to be a good term to unsimplify it, to break it up into a couple pieces. So long as they're cleverly broken up into, so long as the pieces are cleverly chosen, winner winner chicken dinner, this will lead to good things. Let's try another example. So suppose someone gave you this one, 6x, oh sorry, 16x. At first you may not know how to split it because there's really so many ways that you could split it. Someone could say, well, maybe we should do 10x plus 6x. Yeah, maybe. Somebody else might say, maybe we should do 12x and 4x. Well, yeah, maybe. Somebody might say 20x and negative 4x. Well, yeah, maybe. We could be here all night. The possibilities are really, really endless. Again, there's a trick to choosing this, but suppose you go on and you choose the right combination, just the right combination. It might just happen to look like this. Maybe we should split it up as x and 15x and see how it goes. Just saying, let's try it. X, that's 1x and 15x. Just double check really quickly that you really are splitting that. If you were to add them together and simplify like terms, you would get it, in fact, the previous line. And let's see how it goes. This part is just by inspection. I split 1x plus 15x into from 16x. Here I could factor out an x. If I did that, that would leave a 3x plus a 1 there. Again, a quick check to see if you did it right. 3x times x would be x squared. 1 times x would be just 1x. Out of these ones I could figure out, first of all, it would help if I write it correctly. Out of these ones I could factor out a 5. And that would, of course, would leave us with 3x plus 1. 3x plus 1. And so now you've done it successfully. 3x plus 1 and 3x plus 1 matches on both of these. So you could factor out a 3x plus 1, and that would leave an x plus a 5 in there using the distributive law. And that right there is beautiful. You successfully split the middle term into 4 items, so that now you have 4 items. You group these two, group those two, using the same techniques from the previous section, and now we've successfully factored the trinomial into the product of two binomials. Very nice. Let's try that again.